Okay, we're back for part two. So here we have some questions that I've set up for this part two. We're into the probability stuff now. So we're going to do a contingency table question, a probability trees question, binomial distribution question, and a normal distribution question. So with the contingency table question, this one, once you know what you're doing, it will be very fast because you're just looking up a number on a table, basically. All right, so it says if you select one at random, what is the probability that they buy product X? Okay, so we've got this table that shows our 50 customers, and they're split up into different categories based on their age and based on which product they buy, product X or product Y. And we want to know what's the probability a randomly selected customer buys product X. So we just look at, hey, 22 total customers buy product X out of 50. So the answer is just 22 out of 50. Right, so 0.44. And that's it. It's that simple. What is the probability they are 50 or less? Okay, so here's the over 50. 50 or less, that's the 30 to 50 group and the under 30 group put together. Right? So for this one, we need to look at these 16 people and these 14 people put together. Right? So that's going to be 14 plus 16 out of 50. Right? So 30 out of 50. Or 0.6. What's the probability they're over 50 or by product Y? Now, this is where we're going to have to start using our probability knowledge. This is where it gets a little bit trickier. Because you have to remember with the ORs, we're looking for the people they have to be over 50. Well, that's, let me use blue here for this one, right? So over 50, that's these 20 people are over 50. And the people who buy product Y, well, that's these 28 people, right? So you might think, oh, we're going to do 20 plus 28, and that's going to be all the people who are over 50 or buy product Y. But if you do that, what you've just done is you've double counted these 8 people. Because these 8 people are over 50, and so they're part of the 20, and they're also buying product Y, so they're part of the 28. You've counted them twice. So we don't want to do that, so we subtract off that 8 people where they overlap, right? The over 50s plus the product Y minus the overlap so that we don't double count them. We only want to count them once. And this is still out of 50. In fact, all of these are going to be out of 50 until we get to the conditional probability. If you don't have a conditional probability, then everything's going to be out of this grand total. Right? So what do we get here? We get 40 out of 50 or 0.8. Right? So that's the OR, right? The OR is a little bit of work. It's not quite as easy as the other ones. What's the probability that they buy product X and are under 30? This one's easy again. Ands are actually very easy. When you see an and, that just means it's the overlap, right? They have to be the people who buy product X and be under 30. So that's these 7 people. That's it. Those are the only people who are under 30 and buy product X. So you're just doing 7 out of 50. So 0.14. Right? Those are the only people who are under 30 and buying product X. Everyone else is either buying product Y or they're over 30. So that's it. Right? So the ORs are a little bit trickier, the ANDs are easier. And then finally, we've got this, what's the probability they buy product Y if they're over 50? So this is a conditional. We've been given that they're over 50. Right? That is given. So what that means is that we're only going to look at this group of people, the over 50s. We're only looking at these people. There are 20 of them. Out of those 20 people, 8 buy product Y. So the answer is 8 out of 20. Which is 0.4. Okay. So when we have a given, that means we're going to restrict our view. We're only going to look at that row or that column or whatever has been given, right? And this one, the order is important, right? Because if you reversed it, you would get a different answer. If I asked you, what's the probability that someone's over 50 if I know they buy product Y, well, then I'd have to look at the product Y column, those 28 people, and the answer wouldn't be 8 out of 20, it would be 8 out of 28, right? So we have to pay attention to which one is the given, which one do we know, and which one are we wondering about, right? We know they're over 50. We're wondering what's the probability they buy product Y. All right, and so this is our basic contingency table stuff. But there's sometimes in these questions, there's a little add-on, which is about selection without replacement. So if you select two customers without replacement, what's the probability that they both buy product X? So we've already done buy product X. It was 22 out of 50, right? So if I select one, 22 out of 50, that's the probability that they buy product X. But the second one now, I have to select another one. And it's without replacement. That means that I'm not allowed to select the same person twice. So I no longer have 50 people to select from. In my group, I only have 49 people left. Right? So this is going to be out of 49. And then how many buy product X? Is it 22? Well, no, because one of those 22 people I already took out. Right? That's the person I've already taken out. I already chose them first. Now the second one needs to buy product X as well. And there's only 21 people who buy product X left in the pool. So we get this. 22 out of 50 times 21 out of 49. So we get our calculators out. And we do that. And we get 0.1886. All right, that's the way they both buy product X. And that seems straightforward enough. And now when we go on to exactly one buys product X, you might try to use the same technique. And we have to use the same technique, but we have to pay attention to another thing as well. So let's go through it again. Let's say exactly one buys product X. Okay, so let's say we got one who buys product X, the first one buys product X, and the second one buys product Y. All right, so let's do that. Well, if the first one buys product X, that's 22 out of 50. And then there's 49 people left to choose from. And how many of them buy product Y? Well, it should be 28. Because there were 28 to begin with. And then the first person I chose, they picked product X. So there are still 28 product Y buyers in the pool. Right? So we had 28 out of 49. But you can't stop here because the other thing we have to pay attention to is the order, right? This is if they buy product, the first person buys product X and then the second person buys product Y. But what if the first person buys product Y and the second person buys product X? That's a different order. It's actually going to be equally likely, right? If you actually try that out, you'll see, oh, we get the same probability, right? So we can just multiply this one by 2. We can just double it. Okay, so we take the probability of it happening in a particular order, and then we multiply by the number of orders in which it could happen. Right? Which, when there's only two people, there's only two ways this could happen. It's either X then Y, or it's Y then X. Right, so we're going to do this. We're going to do 22 out of 50 times 28 out of 49 times 2, and we get 0.5029. And that's our answer. All right, the number of orderings can get more complicated if you were selecting 3 people without replacement, or even more complicated if you're selecting 4 people without replacement. So if you have to do that, right, then counting the number of orders in which a thing could happen can get more complicated, right? If I have to select exactly one Y out of 3, then I've got like YXX, XYX, XXY, right? So I've got 3 different orderings, and you can see the complexity just grows a little bit with each time we increase the number of selections. Right? But for a short little question like this, we're probably going to have a small number of selections, like 2 or 3, and it's not going to be too complicated. All right, so that's our contingency table question. We're going to move right along. to our probability trees question. At an ice cream store, 40% of customers order 2 or more scoops, with the rest ordering just 1. Of the customers ordering 2 or more scoops, 70% get a cone and the rest get a bowl. Of the customers ordering just 1 scoop, 80% get a cone. So we can use this to build a probability tree. So what we've been given is that we have some people getting 2+ scoops, and we have some people getting 1 scoop. And then of the people getting 2+ scoops, some of them get cones, others get bowls. And same with the people who order 1 scoop. Some get cones, some get bowls. Right? And so we've been given some probabilities, right? 40% order 2 or more. So this is 0.4. That's our 40%. If they order 2 or more scoops, there's a 70% chance they get a cone. So that's a 0.7 up here. And if they order just 1 scoop, there is an 80% chance they get a cone. So that goes there. And this is all we've been given. But what we're going to do now is we're going to fill in the gaps. So we know that every branch, every time we branch out from a point, the probabilities have to add up to 1. Right? So if this is 40%, then the rest of them must be 60%. Right? These have to add up to 1. Right? So just do 1 minus 0.4. Same thing up here. 1 minus 0.7 is 0.3. And 1 minus 0.8 is 0.2. Right? We're just making sure that these all add up to 1. 0.8 plus 0.2 adds up to 1. 0.7 plus 0.3 adds up to 1. 0.4 plus 0.6 adds up to 1. So that's all set. And now we're going to find what we call the joint probabilities. The joint probabilities are the ands, right? So what's the probability that someone orders 2+ scoops and a cone? What's the probability someone orders 2+ scoops and a bowl? What's the probability someone orders 1 scoop and a cone? What's the probability someone orders 1 scoop and a bowl? And so these probabilities, right, we're going to have to multiply to get them. So we multiply along each branch. So for 2+ scoops and a cone, we do the 2+ scoops times the probability that they get a cone given that they had 2+ scoops. So we're doing 0.4 times 0.7. So that's 0.28. For the probability of 2+ and a bowl, we do the 0.4 times the 0.3. And that's going to be 0.12. And for the 1 and a cone, we're going to do 1 and a cone. So 0.6 times 0.8. And here we get 0.6 times 0.2. Right, so this is 0.48. And this is 0.12. So these are the joint probabilities. And that actually answers part A, right? Orders 1 scoop and gets a bowl. We've got that here. That's this one down here. That's the 0.12. We've got that. Right, so that's sorted. What's the probability that someone gets a cone? Well, okay, so now we have to figure out what's the probability someone gets a cone. That's not actually any of the things we've got here, right? But what we can do is we can notice that all of these 4 groups are mutually exclusive, right? They have no overlap. All 100% of the customers fall into exactly one of those 4 categories. These numbers, they add up to a 1, right? So everyone falls into exactly one category. So if we want to know who's getting a cone, we just have to look at these people get a cone and those people get a cone. And we just put them together. Right? So the probability that someone gets a cone is 0.28 plus 0.48, which is going to be 0.6 0.76. And so that's our answer here, 0.76. And we just added these two together. Very simple, right? These people get cones, those people get cones, everyone else gets bowls. Right? If we want to know what's probably someone gets a bowl, well, we would just add up the 0.12 and the 0.12, right? We would add those together and we would get 0.24. So that's a thing we could find as well, right? So I could just write that down if I want here, right? The probability that someone gets a bowl. We're not going to need this, it turns out, for this question, but it's 0.12 plus 0.12 equals 0.24. So the last thing we need is what's the probability that someone orders a scoop given they got a cone? All right, so the probability that someone orders one scoop given they got a cone. So our basic probability formulas tell us that this should be, by using a conditional probability formula, this becomes the probability that someone ordered one scoop and bought a cone divided by the probability that they bought a cone. And we sort of divide these two things. That's what our formula says. So the one and a cone, that is this group, the 0.48. These people here. And the probably they got a cone, we already did that over here, right? That's the 0.76. And so what we get here, right, is 0.48 divided by 0.76 gets me 0.6316. And that's my answer. Okay, and I could solve any of these conditional probability questions in the same way. What's the probability they ordered 2 or more scoops given they got a bowl? I would just do the same thing with the and then the dividing. And it would work out. Okay, so this is how we would do a question that involves a probability tree. And we're going to continue moving right along. And here, oops, I pressed the wrong button. Now we're going to do a binomial distribution question. So if 15% of your products have defects and you randomly select 6 products, what is the probability that exactly 3 of them have defects, more than 1 has defects, between 1 and 3 has defects? In this case, we are going to answer all of these by just looking at a table. There's a table on your formula sheet that will have all the information you need. Right now, the table, it sometimes changes from term to term exactly how the table looks. I'm going to show you the table that we were using last term, so I'm hoping it's up to date. Just so you know, it looks the same, I hope, when you get yours. Right? If it doesn't, it should look similar at least. Right? So on the table, the important things we're going to need to look up are the number of trials. So in a binomial question, you always have a certain number of trials, number of times you're doing a thing, right? So in this case, it's the 6 products. We're selecting 6 products and we're testing them for defects. So we have 6 trials. So we would write n equals 6. That's the n for number of trials. And then the probability of success per trial is p, and that's the 15%, 0.15. That's our probability that the product has a defect. Right now, with these questions, right, we get to define success to be whatever we want. So you might think finding a defect isn't really a success, but you know, we can define it to be a success if we want to, right? We get to decide what is success and what is failure. And maybe for us, finding a defect is a success. So that's fine, right? So we're going to want to know what's probably exactly 3 of them have defects. So I'm going to have to put the whiteboard away this right now to show you instead the table. So just give me a sec. I'll bring up the table here. And here we have the table, and we can see there's actually a bunch of different tables here, or different n's. We want n equals 6. We want this one. You see we got long lines, right? So the n equals 6 table is this whole area. That's the n equals 6 table. That's what we want. And in particular, we want the column that corresponds to 15%, which is, if you look up here, the probability gives you the column, and 15% is there, right? So we want this column here, from here down to here. Right, this is the table, the n equals 6, and then this is the column, the one that starts here, going down. So when they say, what's the probability that exactly 3 have a defect? Well, 3 is right here. That gives us the row. Right, so we have the column based on the 15%, and the 3 giving us the row. So the answer is 0.041. That's the probability that exactly 3 have defects. When they say, what's the probability that more than 1 has a defect? Well, we're just going to take the probability that 2, 3, 4, 5, or 6 have defects and just add them together. So we're going to do the 0.176 plus the next one then, which is the 0.041, plus the next one down, which is 0.005, and then the others are zeros, so they don't help, right? So then on my calculator, I get 0.222. Right? 0.222 is what I get. If you find yourself on a very large table and you don't want to add up all the things greater than 1, what you could do instead is you could do, all right, I'm going to take this one and that one and put them together. 0.377 plus 0.399 gets me 0.776. And what I can do then is I can do 1 minus that. Right? Because those together are the things I don't want, really, right? And so if I do 1 minus that, I should get the part I do want. Right? Which on my calculator, if I do that, I get 0.224, which is slightly different than I got doing it the other way. That's just because of rounding. Unfortunately, these are rounded. So, you know, when you add them up, you're not always going to get exactly the right answer, but you'll be very close. Right? And it shouldn't be a problem for the marking, right? The marking should accept it either way. And then the other one said between 1 and 3, right? So between 1 and 3, okay, so we're going to go 1, 2, or 3. And we're just going to add them up, right? So 0.399 plus 0.176 plus 0.041 gets me 0.616, and that's my answer. Right? So these ones are all answered just using the table. Right, and if that was a little bit fast for you, you can just go back and rewind and pause and check that out. Right, just make sure you know where to find everything. The N gives you the chunk of the table you're looking at. The P gives you the column, and then each question, the number they're talking about, gives you what rows you're supposed to be looking at. 3, more than 1, between 1 and 3, those sorts of things. So that's how we would handle a binomial question using the table. Right, there's also formulas, but if you have the table, you don't need the formulas. And the formula sheet in this course usually has the table. All right, so the last type of question we're covering today is normal distribution question. Oh, I didn't type in an important phrase here. I should have said scoops of the ice cream store have a mean weight of 108 grams. I should have said scoops of the ice cream store have a mean weight of 100 grams with a standard deviation of 8 grams and are normally distributed. Because if we don't say that, we can't just assume it. We don't get to just assume that things are normally distributed. At least not yet, not until we have the central limit theorem, and that comes later. So for now, we have to say we're assuming that they're normally distributed. So we have a normal distribution question, and we've got this mean here. That's our mean, and that's our standard deviation. And so what we're going to do now is we're going to say, all right, if we order a scoop, what's the probability that it's under 100 grams? So if we wanted to draw the picture, and you don't have to draw the picture on your test, but if you wanted to, look something like this. Here's 108, right? That's the mean. It's right in the middle. Under 100 grams, well, if this is 100 over here, then we're looking for this area. And what we're going to do is we're going to get that from a table. But in order to use the table, we have to convert from our variable, which I can just call x, to z, the standard normal. In the standard normal distribution, the mean is always at 0 and the standard deviation is always 1. Right, up here the standard deviation was 8. And so we're going to convert from our normal distribution to the standard normal distribution. And so what that means is I know what the 108 becomes. That becomes a 0. But what does the 100 become? It becomes some z-score. These areas should be the same. This is the whole idea here of normal distributions using the table that we're going to use, is if we convert from whatever distribution we've got to the standard normal distribution, then we can look up at the standard normal table. And that table will have all our answers for us. Right, so under 100 translates to under z. What's z going to be? Well, we have a formula for that. Z is equal to x minus the mean over the standard deviation. So this is going to be 100 minus 108 divided by 8. And so that's going to get us negative 1.00. And we always round to 2 decimal places for these tables because that's what the table has. When I'm using the normal distribution table, it has 2 decimal places on it. And so I need to round to 2 decimal places every time. All right, so here we go. We're going to take this negative 1.00 and we're going to look it up on the table. How are we going to do that? Well, the negative 1.0 is going to give us the row. Right? The number to the left of the decimal place and the first decimal place together give you the row on the table. And the second decimal place, that gives you your column to look at. So we're looking at row negative 1.0, column 0. And that's going to give us the answer, right? Because the z is negative 1.00. And we want the area to the left of z. And the table is just going to give it to us. Right, so let's quickly flip over to the table now. So on this table, I'm going to pass all the binomial stuff. Here we are, standard normal distribution. Right, so the column is 0.000. We're in this first column here. The row is negative 1.0, so I scroll down until I get there. Negative 1.0, the very first column, this gets me this number, 0.1587. That's my answer. 0.1587, I just needed to know where to look on the table. Again, if it's fast, you can rewind, just see how I looked that up. Right, column 0.00, row negative 1.0. And we get 0.1587. That's my answer. For part B is the same, but it says over instead of under. And so all I need to show you here is if you have a question that asks about over instead of under, you find the under, and then you just say, well, it's the opposite of that, right? It's 1 minus this. 1 minus 0.1587 is going to be 0.8413. And there we go. Right, so if they ask about under, you just use the number from the table. If they ask about over, you look up the number from the table that you would get for under, but then you do 1 minus the answer, right? Because this is saying if like 15.87% of scoops are under 100 grams, then everything else, right, 100% minus that, so 84.13% should be over 100 grams. All right, so that's how we do over. Next up, we need to do in-betweens, right? So between 110, which is going to be around here, is 110, and 120, which is going to be somewhere over here, we're looking for this green area. And how are we going to do it? We're going to do the same thing. We're going to get Z-scores, and then we're going to convert. And then we're going to look them up on the table. Right? So the 110 is going to go to something, and the 120 is going to go to a different thing. Right? These are going to convert. We use the same Z-score formula to convert them. Right? So we're going to do first 110 minus 108 over 8. That gets me 0.25. My first z-score. My second z-score, I'm going to use the 120, right? So 120 minus 108 over 8, that gets me 1.50. Right, so there we go. We have our two z-scores here, which we could draw on our diagram if you want, right? Obviously, the diagrams are not strictly necessary, but they can help you figure out what's going on. So now what we need to do is we're going to look up both of these on the table. So I'm going to look up 0.25, and I'm also going to look up 1.50. So let's go back to our table here. So the first page of the table is all negative numbers. So if I want positive numbers, I got to go to the second page. So I'm going to look for 0.25, right? So row 0.2, column 5 gets me this, 0.5987. All right, that's my first one. My first lookup is 0.5987. My second lookup is 1.50, and that should be here, right? 1.50. So 0.9332. Right, so those are the two numbers that I get. So I'll write those down on my whiteboard here. So this gets me from the table 0.5987, and this one gets me 1.5319. And what I need to do here is I need to subtract these. Sorry, what am I saying? I don't know where that number came from. I had something on my calculator and I must have pressed the wrong button. But anyway, it was supposed to be 0.9332. Those are the two numbers I looked up. Right, so I have to subtract these. Right, so I'm going to do 0.9332 minus 0.5987. You always do the larger one minus the smaller one, so you get a positive value. And we get 0.3345, and that's my final answer. That's the area, this green shaded area, between 110 and 120 grams. So 33.45% of scoops fall in that weight range. Okay, and if you want to know why are we doing that, well, if I do, first of all, this area gets me everything to the left of here, everything to the left of 1.5, and this area is everything to the left of 0.25, and the area I want, this green area, falls in between them. So if I take the dark blue area and I subtract the light blue area, I should get that green area in the middle, right? That's what I'm subtracting. That's why the picture helps a little bit, right? But you don't need to draw the picture. You can just remember for these between questions, you're going to always subtract. But you don't subtract until the end, right? Students will sometimes get this wrong by subtracting the z-scores and then looking up the answer on the table. That's not going to get you the right thing. That's going to be totally wrong, right? You have to find both z-scores, look them both up on the table, and then subtract those answers. That's how you get your number. Okay, so now we've got one more question, and it's a very different question. This is a working backwards question. For this question, we've got the heaviest 1% of all scoops fall above what weight? So on our chart here, right, there's some number here, x, and we don't know what it is, but the idea is that the area to the right, that area should be 1%. Right, so if we draw the same thing over here, there's some z, and again, we don't know what it is, but that area should be 1%. Okay, so what we need to do now is we're going to work backwards. So on the questions we've been doing so far, we went from a number, x, to z, to a probability from the table. Here, we're going to take the probability on the table, find z, and then find x. Okay, so we have to find what z-score would give us a 1% here. Now, In this case, it was the heaviest 1%. So it was up here on the right. If it was on the left, things would be a little bit different. Because the table naturally gives us things on the left. Right? If you remember what the table is doing, it's giving us the area to the left of the number. Right? That's why when we wanted to do under 100 grams, we just use the answer from the table. But when we wanted to do over 100 grams, we had to do 1 minus the answer, right? In order to make it work. So same thing's happening here. We want the heaviest 1%. So we want this 1% to be over a certain amount. So that's not going to be what we want exactly. What we on the table, what we're going to look up is the area to the left. What's the area to the left? Well, if there's 1% on the right, there must be 99% on the left. Right? So we got our 99% on the left. We're going to do, right? We're going to do 1 minus the 0.01 equals 0.99. And when we're working backwards, we always go to 4 decimal places because that's what the table's got. Right? When we're doing our forwards questions, we use 2 decimal places. When we're working backwards, we use 4. So now the trick is we have to figure out on the table, what is the z-score that would give us this answer? Fuck. Sorry about that. My monitor went black for a second, and I thought I lost everything. I thought my whole system had shut down. It was only the monitor. The monitor lost power for a second. That was very scary. Oh, I've been recording for a long time. That would be very bad to lose all that. Yeah, so we're still here. Right, so we've got what z-score would give us 0.9900. So let's go to our z table. So now we're looking up 0.9900, but we're not looking up row and column, right? Now we're trying to find it in the table. Trying to find 0.9900, and it's not exactly here. These are the closest we can get. Right? 0.9900 is somewhere in between these two numbers. So we just have to pick the one that's closer. Right? And this one is just ever so slightly closer. This is the closest we're going to get to 0.9900. And so what is the z-score that would give us that? It is 2.3 for the row. And then for the column, we're going to have to scroll up. 3. So 2.33. So we get z equals 2.33. All right, that is this z-score here. And so now we can convert up to get x. We convert up to get x by using the same formula, right? I could write 2.33 is equal to x minus 108 over 8 and do some algebra, but it's not necessary to do algebra because on your formula sheet, they already have done the algebra for you, and they're giving you the rearranged version of this, right? Which is that x is equal to z times the standard deviation plus the mean, right? So in our case, it's going to be 2.33 times 8 plus 108. And that's going to be 126.64. All right, so that is the cutoff. Any scoop heavier than that is in the top 1%. Right? It's a scoop that's really very big compared to the other scoops you normally get. All right, and so that's how we do all of these normal distribution questions. We can go forwards or backwards. Right? For forwards, we have under or over or in between. For backwards, we just have like the top whatever percent or the bottom whatever percent. If we were doing the bottom 1%, the question would have been very similar. I just would have skipped the 1 minus at the beginning. I would, instead of looking at 0.9900, I would have looked up 0.0100 on the table. That would be for the smallest 1%. Right? We have to do the 1 minus because we have the largest 1%. We have the top end of the table. Okay, and so that's it for normal distribution. That's all the questions we're going to do in this part. I hope you found it useful, and good luck on your test.